So proposition okay, maybe. The proposition is that x, okay, no. So let x be a non-empty affine variety, then x is irreducible if and only if coordinate ring at x is an integral domain. And the proof is proof by contradiction in both directions. So to start with, we can start with this direction. We prove the contrapositive. So we want to show that if x is irreducible, then a coordinate ring at x is integral domain is the same as showing that assume we have two non-zero elements such that their product is zero. So we're assuming this is not an integral domain, then so this is zero. This I claim this holds, and so by the relative nullstellensatz, this is x, right? And since so by the bijective property of the relative nullstellensatz, this has to be proper. This has to be proper. These are closed proper subsets. So then x is irreducible. So, and this is the same statement by the contrapositive. So okay, if I want to show the other direction, then we'll assume that x is reducible. So we show this other direction by the contrapositive as well. So we want to show that if the coordinate ring at x is an integral domain, then x is irreducible. This is the same as showing that if x is reducible, then it is not an integral domain. So assume. So assume x is reducible. Proper. So we can write this proper closed subsets here. Okay, then this is non-zero by the relative nullstellensatz, and this is also non-zero because only this equals zero, right? Right. So the only element in the coordinate ring at x that well, yeah. So okay, this is the only thing that's non-zero, that is zero. So these two are non-zero, or I mean they're not empty. So there's some f sub 1 in here, f sub 2 in here. Right. Okay, and these are non-zero, but now so now let me see. So yeah, okay, I think I want to claim that this is zero. And why is that? Yeah, okay, so that's because okay, so let me see if I can remove this. So this is the same as this, right? And this was x, so this equals 0. But notice that these are both ideals, and since f sub 1 is in x sub 1, then when multiplying by f sub 2 here, this is still in I x of 1, and the same way f sub 2 is in I of x sub 2, and so f sub 1 multiplied by this is still in here because both are ideals. So that means that f sub 1 multiplied by f sub 2 is in this, right? It's in this intersection, but then it has to be 0. But by assumption, they were both non-zero. And so since both f sub I are in the coordinate ring, this is not an integral domain, and we are done. So and